So let's solve this example on the left here with the two masses around a pulley. As I told you before, we want to find two things. We want to find the acceleration of the system around the pulley, and we want to find the tension in the string. Both are going to be equal for the two masses. There's just one acceleration for the whole system and one tension for the whole string. So what we need to do first is, as always, to make our free body diagrams. So in this case, because we have two objects, we're going to need two free body diagrams. So we can do them side by side. We are given numbers now. So mass 1 is of 2 kilograms and mass 2 is of 3 kilograms. Because this one is heavier than this one, we know that it is going to go to the right. If this one was heavier, it would go to the left. But in this case, it's going to accelerate to the right. So let's draw our free body diagrams. I'm going to draw here the one for mass 1, and I'm going to draw here the one for mass 2. So as always, we start with the force that affects every single object in the universe, no matter where it is or what it is doing, which is the force of gravity, or weight. So we have downwards, the force of gravity, and that's for both. And we know that force of gravity is given by mass times g. So in this case, because mass 1 is 2, we have 2 times 9.8, which is 19.6 newtons. But in this case, the weight, which is also m times g, is going to be 3 times 9.8, which is 29.4 newtons. Okay, so we have the weight for both. But there's also a tension, as I was telling you. So that's what we had drawn before. There's a tension because each of them are held by a string. So there's a tension upwards for both. And as we were saying, this tension is the same for both. So we don't have to name them T1 or T2. And that's it. There's no surface, so there's no normal force. There's no spring, there's no applied force, there's no air resistance, there's nothing else. These are the only two forces acting on each block. So like in the previous class, the next step is to write an equation, Newton's second law. So force equals mass times acceleration, and add all the forces and equal them to mass times acceleration. So again, we have two objects, we have to do that twice. So we start with the first one. So force equals mass times acceleration, and here we're talking about net force. So the net force here, so what are we going to do? We're going to call positive the one that goes in the direction of the motion, and negative the one that doesn't go in the direction of the motion. I think this is the easiest way. Some people prefer to just call up positive and down negative. You can do it whichever way makes more sense to you, but look at my way and see if it helps you. So my way is, if it goes in the direction of motion, it's positive. So for M1, because it's going to go up, tension is positive. So we have tension. And then weight is going to go downwards, so it's negative. So we have negative minus our weight, which is 19.6. And that equals, that's the only two forces, mass times acceleration. So the mass for mass 1 is 2, and the acceleration is just a. That's all we can do. We don't know a, and we don't know t, so we can't solve this equation. But it's fine, because we have another object. So that object is going to help us solve this equation too. So we do the same for this object. So we have net force is mass times acceleration. And now mass 2 will go downwards. So what was negative here will be positive here. Because it will go downwards, the weight is positive. So we put the weight first in positive, 29.4. And then minus tension, which is opposing the direction of motion, so it's going to be negative, so minus t. Those are the only two forces, so that equals mass, which is 3, times acceleration. So what we have here is two equations and two unknowns, and that is a system of equations. That is something that hopefully you learned how to solve in math class. So we have two unknowns, which are t and a, but they're the same for both equations, so we can solve them at the same time. So what I like to do is this method that is going to hopefully help you a lot in this, which is to add the two equations. So you can solve this whichever way you want. You can do substitution, you can do elimination. If you've heard of any of these methods, you can put it in your calculator and solve it with your calculator if you know how to do that. You can use matrices, whatever you've learned in math class, but I'm going to show you my method in case it works. So what I do is I add the equation. So I take this equation, whichever of the two, I take them and I put them one under the other. So I'm going to put it down here. T minus 19.6 equals 2a. And I'm going to add the equations. I know that might be a little crazy. Maybe you've done it before, maybe you haven't. But you can do it as long as you add the left with the left and the right with the right and equal it. So we're going to have our equal sign anyway, which is the sum of this plus this. But we're going to add this left part with this left part and this right part with this right part. So we have 29.4 minus t plus t minus 19.6. So if you notice here, we have a plus t and a minus t, and these two will cancel out. Yeah, when we add the t equations, we're going to add t minus t, which cancels out. So what we're going to get is just the numbers, 29.4, and then minus, because we have a negative, minus 19.6. So that's what we're going to get on our left side. And on the right side, we have 3a and 2a. So if we add 3a plus 2a, we get 5a, because 3 plus 2 is 5. So the equation that we have left is 29.4 minus 19.6 equals 5a. That's when we get our calculator and solve this left side. So we have 29.4 minus 19.6, which gives us 9.8. So on this side we have 9.8, and on this side we have 5a. Therefore a is, and we pass this 5 to divide to the other side, so we get that a is 9.8 over 5. Let's put that in the calculator. I don't know what that gives. 9.8 over 5 gives us 1.96. So we get our a. I'm going to continue doing it here, sorry. So from this equation, from this equation, we get finally that a is 1.96 meters per second squared. So what we did here is try to solve for a by disappearing the t's so that we didn't have to worry about them, solving for a and getting a without the t. But as I told you before, we also want to find t. And now that we have a, it's really simple because we can use either of these equations. So I'm going to use this one just because it has t ready for us to solve here on the left side. So from this equation, so let me copy it again here, t minus 19.6 equals 2a. Okay, so we had this already, but a is 1.96, so we can put that there. T minus 19.6 equals 2 times 1.96. We can put that into the calculator. 2 times 1.96 gives us 3.92. So t minus 19.6 equals 3.92. And finally, to solve for t, we add 19.6 on the other side. So we do 3.92 plus 19.6 gives us 23.52. So finally, we get our t. So t is just 23.52 newtons. And that's it. That's how we solved the problem. So we had two equations and two unknowns. I used my method, but as I told you, you can use whichever method works for you to solve systems of equations. And that will allow you to calculate A and calculate T. And that's how you solve this problem.